Download this code from codegive.com, link in the description below. Tutorial: Gradient-based learning for designing neural network models. Gradient-based learning is a fundamental technique used in training neural networks. It involves adjusting the weights of the network based on the gradient of the loss function with respect to the weights. This tutorial will cover the basics of gradient-based learning, explain key concepts, and provide a code example using Python and TensorFlow. 1. Understanding the basics. 1.1 Neural network structure. A neural network consists of layers of interconnected nodes, neurons. Each connection has an associated weight, which can be adjusted during training. The structure typically includes: input layer, receives the input data. Hidden layers, intermediate layers that process inputs through activation functions. Output layer, produces the final output. 1.2 Loss function. The loss function measures how well the neural network's predictions match the actual labels in the training data. Common loss functions include: mean squared error, MSE, for regression tasks. Cross-entropy loss for classification tasks. 1.3 Optimization algorithm. Gradient descent is the most common optimization algorithm used in training neural networks. It updates the weights by moving in the opposite direction of the gradient of the loss function. The weight update rule is: W equals W, /eta /dot /nabla l. Where W is the weight. /eta is the learning rate. /nabla l is the gradient of the loss function. 2 Implementation example. In this section, we will implement a simple neural network using TensorFlow to perform a classification task on the iris dataset. 2.1 Prerequisites. Make sure you have the following libraries installed: bash, pip install numpy pandas TensorFlow scikit-learn. 2.2 Load the dataset. Python. Import pandas spd. From sklearn.datasets import load_iris. From sklearn.model_selection import train_test_split. From sklearn.preprocessing import one hot encoder. Load iris dataset. Iris equals load_iris. X equals iris.data. Y equals iris.target.reshape, -1, 1. 1 hot encoding of labels. Encoder equals 1 hot encoder, sparse equals false. Y_encoded equals encoder.fit_transform, Y. Split the dataset into training and testing sets. X_train, X_test, Y_train, Y_test equals train_test_split, X, Y_encoded, test_size equals 0.2, random_state equals 42. 2.3 Build the neural network model. Python. Import TensorFlow STF. Define the model architecture. Model equals tf.keras.sequential. tf.keras.layers.dense, 10, activation equals relug, input_shape equals x_train.shape 1, tf.keras.layers.dense, 10, activation equals relug. tf.keras.layers.dense, y_encoded.shape 1, activation equals softmax, output layer with softmax activation. Compile the model. Model.compile, optimizer equals atom, loss equals categorical_cross entropy, metrics equals accuracy. 2.4 Train the model. Python. Train the model. History equals model.fit, x underscore train, y underscore train, epochs equals 100, batch underscore size equals 5, validation underscore split equals 0.2. 2.5 Evaluate the model. Python. Evaluate the model on the test set. Test underscore loss, test underscore accuracy equals model dot evaluate, x underscore test, y underscore test. Print, f test accuracy, test underscore accuracy 0.4f. 2.6 Make predictions. Python. Make predictions. Predictions equals model dot predict, x underscore test. Predicted underscore classes equals tf dot argmax, predictions, axis equals 1. Actual underscore classes equals tf dot argmax, y underscore test, axis equals 1. Display the results. For I in range, len, predicted underscore classes. Print, f predicted, predicted underscore classes I dot numpy, actual, actual underscore classes I dot numpy. 3 Conclusion. In this tutorial, we covered the fundamentals of gradient-based learning and implemented a simple neural network using TensorFlow to classify the iris dataset. Key steps included defining the model architecture, compiling the model with a loss function and optimizer, training the model, and evaluating its performance. Further reading. Deep Learning by Ian Goodfellow, Yoshua Bengio, and Aaron Corville. Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow by Aurélien Gérin. Feel free to experiment with different architectures, activation functions, and hyperparameters to see how they affect model performance.